In this pencast I will show you how to specify an algorithm using pseudocode. You may think that the proper way to specify an algorithm is to use a programming language, and the result then is a program, a computer program. However, a programming language has very precise rules which makes it difficult to specify an algorithm when you're still in the stage of designing the algorithm. In that case, you don't want to be bothered by the nitty-gritty of the programming language. You just want to think about how should the algorithm work. You may, of course, instead use natural language, for instance English. But the disadvantage of natural language is that it is really too vague. And the result may be that your algorithm is ambiguous. And of course, that's not acceptable. You must have an unambiguous algorithm. So the solution is that you specify, that you think about your problem first in natural language, then you specify your algorithm using pseudocode. And pseudocode, you can think of it as just a subset of natural language, a subset of English, but with some structure and special commands added to it. And once you're happy with your algorithm, you've tested it out on paper, then you can translate it to a computer program in your favorite programming language. Now let's have a look at a very simple algorithm. We start with the following problem. So as you can see, it's specified in natural language. Give the average of 3 and 5. And here you can see the corresponding pseudocode. And pseudocode always starts with the name of the algorithm, and it should be not too long. So I chose for this algorithm the name compute average. And then what follows are several lines, in this case 2 lines, and each line is called an instruction or a statement. And in an algorithm, the statements are executed starting at the top, at the first one, and when it's finished, the next statement and the next statement until the last statement has been executed. In this case, we start by computing the sum of 3 and 5 and dividing the result by 2. And I've chosen to store the results into the computer memory. And that happens here with the arrow. The arrow, or the assignment, makes the results on the right hand side, so that's 4, go into the memory of the computer. So I've drawn here the memory of the computer, and here you see a position in the memory. I put the number 4 there, and I give it a name, and the name is specified here on the left hand side of the arrow. So I always choose a descriptive name. It is the average, so proper name would be average. So now we have in memory a place with the name average and the value 4. And such a place in memory, we call it a variable. And once we've computed the average and put it into memory, the next thing to do is to show it to the user. So that's what happens here in the second line. Show average, it looks up the variable average into memory, so that's here, number 4, and results 4 will be shown to the user. I wrote down here show. I could also have written show average to user. There are not really rules for this. I could also have written print average. or show average on screen, as long as we're clear that it is all about the variable average. Now, this algorithm is not very useful because it can only compute the average of 3 and 5, and a more useful algorithm would be able to compute the average of any two numbers. And we can change our algorithm quite easily to make that happen. We, instead of 3 and 5, we write A and B. And now we get the average of the numbers A and B. What is A and B? Well, A and B are numbers that are specified at the moment the algorithm is started. So once we say compute average, we also have to specify some two numbers. And when an algorithm expects some inputs at the start, then we specify that after the name of the algorithm, we specify which variables are expected. So in this case we need A and B, so I write A and B after the name of the algorithm. So A and B, you can think of them also as a kind of variables, but they are special variables because they get their value at the start of the algorithm. And such a variable, we call it a parameter. So this algorithm has two parameters, A and B. So if we now start the algorithm with, for instance, two numbers 1 and 3, what happens? If we say compute average 1, 3, then A gets the value 1, B gets the value 3. Then the algorithm starts. We get A plus B, so that's 1 over here and 3 over here for B. That's 4. Divided by 2 is 2, and the result is stored in average. So that's stored over here. Average gets as value 2. And then on the next line, the user sees as output the number 2. What should we do if we want to compute the average of 3 numbers? Of course, we can make an algorithm which has 3 parameters instead of 2. So then we get compute average A, B, C. Well, that's not very flexible, because if we then decide to compute the average of 4 numbers, we have to make another algorithm with 4 parameters, etc., etc. And sometimes we just don't know how many numbers there are when the algorithm starts. So let's forget about this one, and let's make it more flexible, and let's make an algorithm that can compute the average of some list of numbers, a list of any size. So in this case we only have one parameter, and that's a list of numbers. You can see that here in my parameter here. I call it numbers, and you could visualize it as follows. So we get a parameter numbers in memory, let's say 3, 5 and 1. So it's a list of 3 numbers, 3, 5 and 1. And we need to do 2 things. To compute the average, we first have to compute the sum of the numbers. And once we've computed the sum of the numbers, we can divide by the length of the list, so the number of numbers. The first part happens here in the first 4 lines. We want to compute the sum of the numbers. Well, we start by saying the sum is 0, and then we have a look at each number, and each number that we encounter, we add it to the sum. So we start off by saying the sum is 0. So I get a new variable sum, and initially it's 0. Then we see a new construct here, for each number in numbers. So what's happening here? This is a way to iterate, to repeat several statements. And what are we repeating? We are repeating all the statements below 4 and above and 4. So this part is what we are repeating. In this case there's only one statement, but you can have any number of statements in a for each. And what do I mean with for each number in numbers? Numbers, of course, refers to numbers to our parameter. And so what I mean with for each number in numbers, that I want to execute anything that is between 4 and end 4 and use the next number in numbers and put it in our variable number. So actually number, you could think of it as also a variable. We'll make a new variable number. So the first time that we get here, a number gets assigned to the first number in our numbers list, so that's 3. So number gets the value 3. And then we execute the statements in our between 4 and end 4, and what happens there, we see that we compute the sum of the variable sum and number. Sum plus number, well, sum is 0, number is 3, so that's 3. And what do we do with that 3? We store it in the variable sum. So that means that we overwrite the old value of sum, which was 0, and we replace it by the new value 3. And then we are ready with our statements for the first loop. Then we can go to our next number. So number gets now as value the second one in numbers. So that's 5. We forget about the first one. Now number has as value 5. And we execute sum plus number again. So that's 3 for sum and 5 for number. That's 8, and we store it in sum. So we overwrite value 3 and replace it by 8. And finally we get to the last of the numbers. That's 1. So number gets the value 1, and we execute sum becomes sum plus number. So sum plus number is now 8 plus 1 is 9, and we store that in sum. So sum is 9. And now we're ready with our for each loop. We have exhausted all numbers, so our loop our for each loop is finished, and we continue with the line before, the line after and for, and that's the computation of the average, because now you can see that sum, the variable sum, contains the sum of numbers. 3 plus 5 plus 1 is 9. Now we have to divide the sum by the length of numbers, and that's what's happening in this line. We divide the sum by the length of the numbers, so that's the number of numbers, and that's 3, and result is stored in the variable average. So I get a new variable, average. The sum was 9, divided by the length of numbers, that's 3, so average gets its value 3. And finally, of course, we show the result to the user. We show average to the user, so we show 3 to the user. And that's the end of the algorithm. The challenge when designing an algorithm is always to think of all possible ways the algorithm may be executed and all the possible ways that things may go wrong. And one of the things that may go wrong here is that the algorithm is executed for a list of numbers which has as length 0. So there are no numbers. What happens then? Well, let's see. The sum is 0. For each number in numbers, the new sum is calculated. Well, there are no numbers in numbers, so we are quickly finished with that part. We move over to the computation of the average, and then we get 0 divided by 0. And of course, that's not possible. So here we have a problem with our algorithm. How can we prevent that? What we can do is check once the algorithm is finished, once the for loop is finished, for instance, we can check if the number of numbers is 0. And we can do this by saying, using the if. We can write down, that's why I left some space, if the length of numbers, this list of numbers, is greater than 0, well, then we're happy and we can continue with computing the average and showing the average. Else, if that's not the case, so in that case there are no numbers, then we can, well, what can we do? We can show some error message. And I also have to be very carefully to specify where my if else ends, and I do this with end if. So it is clear where the statements end that must be executed if the if is true, because that's determined by the word else. So if this part, length of numbers greater 0, is true, and we call this part the condition, then the part is executed, the statements are executed below if and above else. And if the condition is not true, the statements are executed below else and above end if.